I'll introduce to you what is a random forest model in this video, and we'll also see how we can build a random forest model using R. So the outline for this session is that first we'll try to understand the basics of what is basics of machine learning model, and then we'll talk a little bit about tree-based model, and then I'm going to introduce to you what is bagging and random forest because they're very related to each other. So I'll first talk about bagging, and then we will go into understanding what is random forest, and then finally we will build a decision tree model and a bagging model and a random forest model, just to understand the differences between these three types of model, and I'll finally give you an exercise to you know to do at home. All right, so let's get started. So what are the different types of machine learning models that we are familiar with? You know that what is a supervised learning model, what is an unsupervised learning model, and what is a semi-supervised learning model. Well, supervised learning is a type of learning model which has target variables, right? If the data has target variable, then we use what is known as supervised learning algorithms. That means we are showing the algorithm that given a set of variables, the output will look like this, okay, and that output will be in the target data. In the unsupervised learning, we won't be having any target data, okay. So the data, the algorithm learns by itself. It doesn't have the target or a level. So we do not have a level data here, right? Not level data. In semi-supervised learning, it combines both supervised and unsupervised learning in some way, just to improve the prediction. Okay, so we use data where a section of the data is labeled and another section is not labeled. So in that scenario, we use semi-supervised learning, which make use of both supervised and unsupervised learning. Now for this video, we are only concerned about the supervised learning because random forest is a supervised learning algorithm. And supervised learning algorithms could be of two types: regression algorithms and classification algorithms. So the problems could be of regression types or the classification type. Random forest can be used for both types. Okay, so regression type problem could be finding out, let's say, the salary of somebody given some variables, which is a continuous variable, right? Or the house price. So these are regression problems where you are trying to find out the value of a continuous variable. Classification variables could be whether you should give loan to someone or should not give loan to someone. Okay, or knowing that if a given image is a cat's image or it's not. Okay, this is classification. This is an example of classification problem. Now, random forest can be used for both. A typical learning model looks like this. You give training data and use some ML algorithm, and then we build model, what we call as model. Okay, and training data, because this data is historical in nature. We know for sure what is my factors and what is my target. We denote as x and y. Y is the target and x1, x2, xn are the factors. Okay. Now once that is done, we apply the model which has been trained using an ML algorithm to a new data and do the prediction for the new data. New data in the sense which we haven't seen yet. In the future we'll get the data and then we will find out the value of the target, which is the y in this case. Now having this in mind, let's try to understand how we can use a decision tree model to do both regression and classification. Now what happens in decision tree is that we partition the data into subsamples and take the average and majority vote. This is probably one of the easiest way to build a machine learning model. You just to partition the data in some fashion, okay, and how we partition, and I'm not going to get into the details of it. If you really want to learn how the partitioning is done, there is a video on my channel where I have explained very in detail as to how a decision tree model building is performed. So I'll keep it simple. So in decision tree, we just try to partition the sample into different subsample, and then we, depending on whether it's a regression problem or whether it's a classification problem, we either take an average or take a majority vote. In regression problem, we take an average. In classification problem, we take a majority vote, because in classification problem, we were interested to know that whether a particular data belongs to class A or class B. Okay. So the reason why we are interested in majority vote is that if in a given subsample, let's say we have 3 A's and just 1 B, then we say that anything that falls in that subsample is A, because majority is A. So that's why. In a regression problem, let's say price of a house. In a given subsample, if we want to find what the price of a house is, we just take the average of price, because it's a continuous value, right? So okay, so a typical decision tree for a classification problem will look like this. Okay, given with the given factor x1, it gets divided into based on some x2 factor. X2 is, let's say, greater than k, x2 is less than equal to k, and then you have 0 in this subsample, 1 and 1. So let's say we say that, okay, for a given x1 and x2 less than equal to k, what is the value of the target? Well, you come to this place. So depending on the value of x2, okay, so this would be x1, sorry, and here it would be x2, right? X2, let's say, greater than p, and here it is x2 less than p. Okay, and then you come down to either 0 or 1 based on what the values of x1 and x2 are. That's the way you build a decision tree model, which is probably one of the simplest way of building a model. But the problem with this is that there is low prediction accuracy and high variance. That means the error rate would be quite high, because it's quite simple and it doesn't take care of the non-linearity involved. High variance in the sense that you take another training data and build a model, and you will find different, it could be giving a good accuracy maybe in the training data, but when you validate the model in a test data, it may not be that great. Okay, or you could find a high variance, and variance is not a good thing. The error variance should be minimum. The error variance should be minimum for a good model, right? So that is quite high. And why are we discussing about this one? Because this weakness of decision tree model motivates us to learn what is a random forest model. So in random forest, we combine the output from multiple trees. So instead of using just one decision tree, we build multiple decision tree models, and then we combine the output from these models, and that would help us reducing the variance of the final model or the output. Because from mathematics, you must be knowing that when you average something, you actually reduce the variance of something. Okay, and this is from the probability theory, where you take the actual values of different a particular random variable, but you take the average of that random variable across different samples or time, and you will find that the variance is reduced now. So that's one idea we have taken from the probability theory, and the name that is given to this sort of workaround is called ensembling. Although not in full definition, ensembling is also used in many other ways, but this is one way of building an ensemble model. and I would highly recommend you to just see the definition of ensembling in Wikipedia and many other sources, because this is also used in many other purposes. Okay, so don't confuse with combining just models, calling it as ensembling, because there are many ways of ensembling. So we'll also call it as ensembling learning. So the idea is to combine weak classifier, and it's more of a general form, by the way, and then to get a strong classifier. So decision tree, a single decision tree is just a weak classifier, but when you combine, you will get a stronger classifier. So bagging, boosting, random forest are the algorithms which combine the weak decision tree models and give us a much better model. Okay, so how do we know if that's a better one? Okay, so we just compare. In the regression problems, we just compare the square of the error. In classification problem, we take deviance, Gini index, accuracy, and so on, just to compare models if that is improving just by combining different models or not. Okay, before getting into random forest, let's try to understand what is bagging, because random forest is just an improvement on bagging. So let's try to understand what is bagging. So bagging is nothing but, it's called bootstrap aggregation. And so what do we do in bootstrap aggregation is that we just follow three important steps. In step 1, we take random samples from the main sample. Let's say we have this maybe this is the population. We take a random sample. Let's say we just take 70% of the data. Okay, we take 70% of the data. Okay, so this is capital N, this is small n. So taken small n from the capital N, which is small n by capital N is, let's say, 0.7. Then we train model on this sample data, not on the population data, or rather in the subsample data, not on the main sample data. Okay, and now second time what we did is that we took another subsample with 70%. Now with replacement, that means if a data point is present in the first subsample, it could also be there in the second subsample, but it's random. I mean, we don't do it by ourselves. We use some random algorithm to pick the number. So a data point can be in different subsamples. So every data point can be in different subsample. So there is no question about mutually exclusiveness. It's just that we are saying that we are doing it with replacement. Now you keep on doing that for a number of times and build separate models with the subsample on the subsamples. Okay, the first subsample, second subsamples, we could have just k number of subsamples and build k different models. Okay, now the final prediction is just the mean or the maximum mode. Okay, just to give an example, if the price of the house given by the first model built on the first subsample, let's say, is 20, by the second subsample is 19, by the third it is 21, by the fourth model is just the 20, let's say 20, and then there are p times, there's some p model you have built, and this is what the output is from the different models. And the model that we have built it is the decision tree. We just have used decision tree to build a model on the p number of samples, right? The final prediction is just the average of that. If you take the average of these four, it's just the 20, right? So average would be just average would be just 20. Okay, but if you take only the individual model, you will see there is a high variance, there is some sort of variance, but the final output would be closer to the actual value. That's what the essence is. So this is in the regression problem. In classification problem, it will be a maximum mode. That means out of, let's say, p model, 60% say the data is 1, 40% say the data is 0. So the maximum count is 1. Then we take 1 as the final output from this model. So depending on whether it's a regression or a classification problem, we just try to average it out. Okay, so the idea is simple. you have the main sample, take as many number of subsamples that you can. Also, of course, it depends on your computational ability, but take just k number or p number of subsamples, build k number of models, and just average it out throughout, and the output would be the result from a bagging. Okay, and you take the average in a regression problem and take the maximum mode in a classification problem. Now in bagging, so if you have the x variables, all x variables will be used, all independent or all features or factors, whatever you call it, all variables will be used while building the decision tree model, right, for each subsamples. In random forest, we'll try to increase the randomness. That means instead of taking all x variables, let's say you have 10 x variables or 10 features or 10 independent variables, instead of using 10 independent variables in each sample, you just randomize it. Just take, let's say, 6 out of 10 every time. Okay, so that would improve the model by reducing the variance. So that is the essence. You may not find it true all the time, but in theory that should reduce ideally. Okay, and we'll see if that actually will do or not by taking an example. So random forest is just a special case of bagging, where the number of variables used in building your decision tree model in different samples is just less than the total number, and it keeps on changing. Okay, these are the two different things. Okay, so the number of variables is less than the total number of variables, and n is random. Okay, so n could be any number of variables, so it could change the number of the actual variables could be changed, so that random selected. So bagging uses a full set of predictors to determine the splits. Random forest uses a random set of predictors, and that's why it's called random forest. Okay, random set of predictors where it is a full set of predictors. So that is the difference between bagging and random forest. Question is, how do you calculate the optimal number of predictors? How do we know this number 6, that we just want 6 out of these 10 variables? That's important. Well, in classification, we just use the square root of k. If you have k number of variables, the total value is k. Then you take aim, which is the optimal number of predictors, is just square root of k. There is no thumb rule as such. You can keep on changing. It all depends on you. But this one has been seen that this is probably the best way to get the optimal number of predictors in a classification problem. In regression problem, m should be just k by 3. Okay, again, this is not a thumb rule. You can always try m plus 1 or m minus 1 just to see if that works better. So bagging is a special case of random forest when aim equal to k. That means when instead of taking 6, if you take 10 variables, you are simply building a bagging model instead of a random forest. Okay, so the fundamental difference is that you are taking lesser number of predictors while building your random models by taking bootstrap samples from a main sample and so on. So what are the steps we follow? We select bootstrap sample, the smaller sample I told you, right, from the bigger sample, with replacement, and we call that a different training sample, and there will be several such training sample, and train model in each sample, train a decision tree model in each sample. Then select m predictor out of k predictor. If I have total number of predictors available to us is k, we just select m out of it, and we do that randomly for splitting in the sense building the model for classification, let's say. And prediction is the average of the response. If it is a regression problem, then we just take the mean of it. If it's the classification problem, we just take the maximum vote. Okay, maximum vote or the majority vote. Alright, so the few questions: how do we choose the splits, how to select the number of trees, how to select the optimal number of predictors. Now if you're familiar with decision tree, these two questions are very much trivial. How to select the split depends on the type of problem. We can use mean square error for regression problems. We can use Gini index for classification. Right? Splitting your data into different subsamples in a decision tree is always done through either mean square error or with the help of Gini index. How to select the number of trees? So how we go about doing is we build until the error no longer decreases. Okay, we try to keep on building the model till the time we do not find the error rate to be decreasing. Okay, and given the computational power available to us, we should simply maximize the number of trees, and that would, the more the number of trees, the better would be. The likelihood of getting a better model is more. How to select the number of predictors? We have already said. We just try the default value, whether it's the square root of k or k by 3, depending on whether it's a classification or regression problem, and then you can slightly increase or decrease and see what is optimal. So let's build a model to understand. Okay, we are now somewhat familiar with the theory, and will be more familiar once we build a model using R. So we'll get the library onto the R session. This is random forest, and we'll also get tree. So random forest algorithm will be used. Both Bagi and random forest will be used using this library, and the library tree is going to help us building a decision tree model. We'll get a data set from the library mass. So we'll get that from you. So all the library we just get first, and the data set that we're going to use is Boston. It's a data set which has the salaries of different basketball players in the NBA league in Boston. There's a team in the NBA league, Boston something. So that has number of players, and depending on the different factors, the players get different salaries. So we need to build a model that would predict the salary of a given NBA player, and the data set given to us is Boston. So we have got different variables. We are not getting into the details of these variables. It's all acronyms, but so these are all short forms. I am not able to give you the data dictionary, but you can always search. It's a publicly available data, so you can always get the details about these variables. So we have just age, experience, and so on. These are the factors that matters in deciding the salary of a basketball player. So the target variable is MEDV. So this is more of a median salary of a basketball player, and this we will predict based on the other 13. So there were 13 factors or 13 features, and MEDV is the target. Okay, so this is the target. So first we will try to fit a decision tree model, which is the very plain vanilla, the simplest of the type, and we'll see this is the target variable, and we are using all 13 variables as independent variables, and the data we are using is Boston. When you summarize, you will see the residual mean deviance is around 13.55. Okay, whether it's that good or not, we do not know, but we will try to compare with random forest and Bagi and see which one works better. As I've already said, decision tree, although it looks very simple, it's not very efficient. The error rate would be likely to be more in this case, and it's 13%, 13.5% in this case. Okay, so we will build a random forest by calling the function random forest. Target variable is again MEDV, and we are using all 13 variables. However, this in random forest we cannot use all 13 variables. Okay, So we need to find what is the optimal number of variables we'll use by in random while selecting or while building the models in different subsamples. While bootstrapping or trying finding a bootstrap sample, fitting the model, averaging it out, everything will be done by the random forest model. But we just have to tell the algorithm how many such variables we want to use every time we build a model. So we're given it as 6. Okay, 13 is it's a regression problem. So if you divide it by 3, it actually is 4 point something, right? Like 4.2. So you can try with 4 variables, 5 variables, 6 variables, okay, or maybe 3 variables, okay, and see which one is optimal. I've gone ahead with 6 variables. So the keyword here is mtry equal to 6, and this will invoke the random forest algorithm and will get the result. So the residual we're getting here is 9.5, much improvement than what we had received last time, okay, because that was 13 point something, now it is 9.5. So we want the residual to be much less, or rather as minimum as possibly we can have. So it is a very significant improvement from a simple decision tree model. Now we'll do a comparison between bagging and random forest. Now what is the difference? In bagging you use all variables available to you, whereas in random forest you just use a subset of that, whereas n is less than your capital N, total number of variables, subset of variables. So your cap n is 13, we have taken 6 variables, right? So bagging can be used using the same function. Bagging model can be built using the same function, random forest. It's just that you just have to adjust the mtry. So if when mtry is 6, we are building a random forest. When mtry 13, because we have only 13 factors, so total count is 13 and mtry 13, and that's a typical case of a bagging. So second one is bagging, the first one is a random forest. And when you when you build a random forest and bagging, you see that the residual is 9.5 in this case in random forest, whereas it is 10.66. So in this case you see random forest is doing better than bagging. As I have already said, random forest actually increase the randomness. Okay, it is very similar to bagging except the fact that it increases the randomness in building the model by selecting a subset of the total set of variables instead of using the total set, which random bagging does, right? So this is how you build a random forest model. Now how you can use your skills to improve on this? Just try with 5, mtry equal to 5, or mtry equal to 4, or maybe with 3, and see which one is actually giving the minimum residual value, okay, and that would be your optimal or the most efficient model. And of course you can keep on trying using more number of variables, that's another thing, but with the given set of variables just try with different set of mtry. Okay, assignments. Now this is one assignment, you can try it out. Just split the data into training and test data. We have used only training data, right? But when you actually build a model, you build a model in training and then do the testing in test data, right? So now we are sure that random forest works better than decision tree and also works slightly better than bagging in our data set, but we have concluded it by taking only the training data. So I would request or rather encourage you to split the data into 2 sets. One is training, and then find out the error rate in the test data, and that's where you can compare better, because that's the better way of knowing if your algorithm performs better or not. So we compare that for bagging and random forest and decision tree, and that would be a much better validations of use of algorithms for your given data.